Hi, good evening. My name is Dinesh Vijayavardhana. Welcome to my program, Engineer, Designer, and Artist. Now, in my last few videos, I have explained about my company and also this will be a brand new video of what one of the most highly used scenarios in physics. This physics law, when you come to about physics, usually physics teaches about the motions. So it could be either linear motion or angular motion. So let's look at what linear and angular motion is. Now, linear motion is basically moving from one point to another, object moving from one point to another. So we have an object. So it's moving in a straight line, one point to another. So that's A and that's B. So the motion going from there to there is called linear motion. Linear motion usually can have a direction. In physics, we usually with the direction we use equations, or we sometimes assume the direction is as one direction, but it doesn't have to be. It can have multi directions and still use for equations. And the angular motion is, so if you consider, so you have a circle, and that's the center. So that's the center, and so angular motion is if you have a force applied from that point to an object, and it's, let's say, it's attached there, so it keeps moving the circular line. So an object moving in a circular or motion is called angular motion. So let's have like we have crankshaft, we have in a car we have all the crankshafts, the piston rods connected into the crankshaft. So that's an angular motion. Or you can have a belt rod, like a motor. So that's a motor. So that's the motor, and that's a pulley. Or you can say like a saw operating from, like a wood cutting saw operating from a belt rod. So it's probably connected to the axle like that, and that's a saw, and you cut the wood. So the motions there and there, so that they are angular motions. So in engineering, we use mainly linear and angular motion to calculate, but it becomes very complex after a while, but that's the basic idea of it. Now, when it comes to angular motion, I have to discuss that in linear and angular motion, we need to decide what Newton's law is Isaac Newton is a very famous scientist who actually dedicated his life for finding out the force. So this is his famous equation, F equals ma. And in his first law, this is obviously his second law. That's the second law of Newton. His name is Isaac Newton. Because his name is Isaac Newton, the actual force he found, the unit has named after his surname, which is Newton. N. And basically, in his first law, he discussed what a theory. Basically, it says an object have to be if an object is still. If an object is still, you need a force, external force, to move it. So if it is still, you need an external force to move it. Or if it is moving already, so it has a speed or velocity, in order to stop it and make it still, you need external force as well. Sometimes when a car is moving, there is external force on the wheel, like on the tire, which is the friction. That is also what is discussed in the Newton's first law. So either it needs the external force to move an object, or to stop the object, or even to change the direction. So if it is moving in this direction, and if we put a force, so if it is moving this direction, and we apply the force this direction, obviously it will move this way. So it will keep going this way, and it was kept going this way, and now it's going this way. So that change of direction is also in order to change the direction of an object, it also needs an external force. So this is external force, a force applied externally. And is this first scenario, second scenario, and third scenario? Still object pushed in by external force, or object that is already moving is stopped by an external force, or object that is moving but the direction is changed by an external force. So those are the three scenarios. Or if these two scenarios not apply, then that object has to be going in a constant speed. So constant speed means the velocity is constant. Well, that's just a basic idea. Well, I haven't discussed any parameters yet, so I will discuss in just shortly. And so just remember, this is the fourth scenario. The velocity is constant, and it's keep moving with that velocity until for that pretty much keep moving like that. So these four scenarios, that's what Newton's first law is. Now Now I'm going to discuss what the main topic of today, which is linear motion, and angular motion. So I obviously discuss linear is moving from one point to another point in a direction A to B, or angular motion is moving from one point to another but in a circle. So point A, point B, that's the object, it's moving in this direction. It keeps changing in a circle, keep changing direction. So angular direction, and that's the 0, that's the center of the circle. So now let's discuss what are the formula, what are the parameters we used, basic parameters we used in linear motion. Linear motion we use, firstly we use S. S is for displacement. Displacement has a direction. So this is not the distance. It's not distance. It's displacement. Alright? So the unit of this is in measuring meters. The SI unit, international standard SI unit is meters. And then we have time. The time, which is international standard SI unit, is seconds. And then these are the main two parameters. And then if you divide the S by T, then we get another parameter called velocity. So displacement divided by T is velocity. So this is not the distance, this is displacement. Displacement has a direction. So as I said, it moves in a direction. So S divided by T becomes velocity. So velocity is V, or sometimes for initial velocity we use U, and the unit for that is meters. So meters divided by second, so meters per second. And then we have, now if you divide the V by T again, and then it becomes acceleration. So V is m meters per second, and this is second, so meters per second squared. The unit behind meters per second, second squared. And so usually the example of this acceleration is give you a good example is like gravity. So let's say my weight, or I put a ball upwards, a tennis ball. So I give a force upward, a tennis ball, and keep moving, and then keep going, and then stop somewhere there, and then comes back, fall into the ground. So this scenario happens due to gravity. So gravity is a type of acceleration. So the unit for gravity is ms squared. And it is also about 9.81 meters per second squared. So it's one of the gravity, one of the acceleration parameters we commonly use in our engineering calculations. So these are the basic parameters. So now let's look at how we can find out what sort of equations we use. Now for linear motion, now I'm only talking about linear motion. So we use if we in a calculation situation, if you want to find the parameter, the first equation we use is V equals, so this is U plus AT, V equals U plus AT. So that equation is commonly used if we don't know, if the problem does not have one of the parameters. So in this case, the S, there's no S in the no displacement in the equation, so therefore we can use this to find out if we know this, then we can find the time. So usually we should know at least 3 parameters, and then we can calculate another parameter. So that's the first equation. Now the second equation is S plus half AT squared. So that's the second equation we find in order to find if we know the sum of the parameters, then we can use this equation to find any of the other parameters. But in this case, what we don't know is basically in this equation what we don't know is one of the functions we don't know. Let's look at, just try to remember which parameter that is missing there, but I'll come back to that later. So the third equation we use is S divided by 2, no, S divided by T plus U plus V divided by 2. So in this equation, we don't know A. So in this equation, there's no A, so no acceleration in the equation. So we can use, if we don't know the acceleration, we know this, and then we can find the V. So that's one. And the fourth equation is V squared equals U squared plus 2AS. So V squared plus equals U squared plus 2AS. So in this equation, we don't know T. There's no T in it. So I got now, so there's no V, no velocity, final velocity. So U is initial velocity, V equals final velocity. So we all need this initial final velocity. So if we move it from one direction to another, so we have the U here, the initial velocity, and the final velocity Vf there. So I just use U and V. That's how I used to. So U is initial, the final is V, and that is the S. it means. So A to B, U is the initial velocity, V is the final velocity, S is the displacement, and time is time, and then you have the acceleration, or if the speed is reducing, if the velocity is reducing, it's called deceleration, which is also A. So which is a value would be a minus value because it's going down. Usually if speed is going up, it's a acceleration. So so those are the equations we use for linear motion, and then we use same formulas for angular motion. So for angular motion, usually S becomes theta, so angular displacement. Theta is the angular displacement, and then you have time. Time doesn't change, time is time. So angular displacement is that. So coming from here to here, the angular displacement will be that, theta. And then if you divide theta by t, it will be angular velocity, which is omega. Angular velocity, omega. And if you divide the omega by t again, angular velocity by t again, it becomes alpha, which is angular acceleration. So that's pretty much how the basic formulas work. Now let's look at the formulas for angular motion. So now for linear motion, we used, first equation is V plus UAT. V plus UAT. For angular motion, we have, instead of V, so we have two. One is the initial velocity and the final velocity, omega f and omega 0. Initial and final. So it's like U and V, right? So we use omega f equals omega naught plus alpha t. So that's the equation 4. And in this case, like we said, we don't know the displacement, so we don't know no theta, right? And the second equation is S equals ut plus half at squared. In linear motion, in angular motion, you have theta equals omega naught t plus half alpha t squared. So which we don't know the omega f in this case, no omega f. And then third formula, we have S over t equals u plus v over 2. And angular motion, we have theta over t equals omega naught plus omega f divided by 2. So in this case, we don't know alpha, no alpha. And the last equation is v squared equals u squared plus 2as. So in this one, we omega naught, omega f squared omega naught squared plus 2 alpha theta. So that in that equation, we don't know the time, no time. So those are the four formulas that we used for angular and linear motions. So I hope you have learned something out of it. Or now, one more thing. Now, when I discussed earlier, I said that in Newton's law, that there is external force required. So to move an object, or to change the direction, or to change, or to stop it, or then if none of the three scenarios doesn't happen, the fourth scenario is the object is moving constant in a constant velocity. So velocity is constant and keep moving like that. For example, if you put a ball and move it, on an icy track. So if you put this one in ice, there is no external forces, there is no friction, so the ball will keep moving until it hits something, or so in ice we usually say the friction is 0. So in a scenario like that, the formula we have to use is, so let's look at this formula. Now in a situation like this, A is 0, so A becomes 0, there is no acceleration, the V is constant, so A is 0. So when this part is 0, so it ends up with S equals ut. S equals ut, which is displacement equals the velocity times t. So that is how we calculate these basic functions. This obviously this can get very complex when you do the calculation. So I hope you have learned something. Thank you for listening. I'll see you next time.